In this video, I want to have a look at sketching parabolas. So when we're going to sketch a parabola, we're going to find 4 different things. We're going to check whether the parabola is concave up or concave down. So a concave up parabola looks something like this, and a concave down parabola looks something like this one. Then we're going to find the X-intercepts. So when we're talking about the X-intercepts, that's where it crosses our X-axis. So some parabolas will have 2 X-intercepts. So it might cross here and it might cross here. Some parabolas might only have 1 if the parabola comes down, touches the axis, and then comes back up. And some parabolas might not have an X-intercept at all. But we need to find if there are any, and if there are, we need to find where they are. Then we need to find the Y-intercepts. So the Y-intercepts are going to be where our parabola crosses the Y-axis. So in the examples that we've got, that's there, here, and it would be up here as well. And the last thing we need to do is find the coordinates of the vertex of the parabola. So that's its turning point. So in this one, it's just here, and then it's here, and then it's here. So we're going to find the coordinates of that point as well. So let's have a look at a few examples. So our first example, we've got the equation y equals x squared plus 5x plus 6. So the first thing we want to have a look at is whether it's concave up or concave down. So we look to tell that at the coefficient of our x squared term. If the coefficient is positive, or if our x squared term is positive, then it's concave up. If it's negative, it's concave down. So because we've got this x squared here, the coefficient would be a 1 or a positive 1, so our parabola is going to be concave up. The next thing we want to do is find our intercepts. So to find the y-intercept, just like we were doing before when we were doing straight lines, we're going to set x equal to 0. So that would give us y is equal to 0 squared plus 5 times 0 plus 6. And all these zeros sort of cancel out, and we just end up with 6. So we have a y-intercept of 6. Then our x-intercepts. So we're going to set y equal to 0. So we're going to have 0 equals x squared plus 5x plus 6. Now we need to solve this quadratic equation. So a lot of the time you might be able to factorize it. If you can't, you'll have to use the quadratic formula or complete the square. But in this one, we can see that 2 numbers that multiply to give 6 and add to give 5 would be 2 and 3. So we'll have x plus 2 and x plus 3. So that means that either x plus 2 is equal to 0 or x plus 3 is equal to 0, which means that x is equal to minus 2 and x is equal to minus 3. So this equation, this parabola, will have 2 x-intercepts at x equals minus 2 and x equals minus 3. The last thing we need to find is the coordinates of that vertex. So every parabola has an axis of symmetry, and we're going to find that first. So our axis of symmetry will have an x-coordinate that's halfway between our 2 x-intercepts. So this is for our vertex. So our axis of symmetry would have an x-coordinate of x equals minus 2.5 in this case. So halfway between minus 2 and minus 3. Then we're going to substitute that x value into our equation and solve for y to find the y-coordinate of our vertex. So we'll have y equals minus 2.5 squared plus 5 times minus 2.5 plus 6. And that will come out to give us minus 0.25. So our vertex has coordinates minus 2.5, minus 2.5 and minus 0.25. So that's our vertex there. So now we can sketch it showing all of those features. So if we have our straight lines, our axes, that's our x-axis and our y-axis. So on there we're going to have, we know it's concave up, it's going to have a y-intercept of 6, so we'll put that here. It's going to have x-intercepts of minus 2 and minus 3. So minus 3 would be about there, minus 2 is about here. And its axis, so its vertex is minus 2.5, minus 0.25. So that's going to be the point about here. So then we need to draw our parabola in through those points. So this is pretty difficult for me using this tablet, but you're going to come down through the x-intercepts, through the vertex, back up, and through your y-intercept as well. So that's the sketch of our first parabola. Our second example, we have the equation y equals minus x squared plus 8x minus 7. So the first thing we do again is look at the concavity. So concave, because the coefficient of that x squared term is negative this time, this parabola is going to be concave down. Then we can look at our intercepts. So if we look for our y-intercept, we're going to set x equal to 0. So we would have y equals minus 0 squared plus 8 times 0 minus 7. So we would have a y-intercept of minus 7. If we have a look for our x-intercepts, we're going to set y is equal to 0. So we'd have 0 equals minus x squared plus 8x minus 7. So we're not usually used to solving these with negatives out the front of our x squared term. So we can pull all of this over to our other side of our equal sign. So we'd have x squared minus 8x plus 7 is equal to 0. And then it's just a little bit nicer to work with. So we need two things that multiply to give positive 7 and add to give minus 6. So that would be minus 1 and minus 7. So that will factorize to x minus 1, x minus 7 is equal to 0. So we'd have x minus 1 is equal to 0, or x minus 7 is equal to 0, which gives us intercepts of x equals 1 and x equals 7. The last thing we need to do is look for our vertex. So our axis of symmetry will have an x coordinate that's halfway between 1 and 7. So if you add those together, you get 8 divided by 2 and you get 4. So halfway between 1 and 7 is 4. And then we're going to substitute that x value up the top here. So we would have y equals minus 4 squared plus 8 times 4 minus 7. So that would give us minus 16 plus 32 minus 7, which would give us an answer of 9. So our vertex is 4, 9. So if we sketch that then, we've got our x-axis and our y-axis. We'll put in the information that we know. So we know we have a y-intercept of minus 7. So that's going to be down here somewhere. Then we're going to have x-intercepts of 1 and 7. So 1 would be about here, and 7 would be over here somewhere. And then we know our vertex is at 4, 9. So 4 will be halfway between, and 9 would be up here somewhere. So we'd have our vertex here. So now we know our parabola is concave up, so it's going to come up through these points, round and back down. So I'm just going to start sketching it from the top. It's a little bit easier. Down here and through that. Oh, sorry, mine doesn't quite go through on the tablet, but you get the idea. So that's two examples of sketching parabolas.